So good day to you, Sir Jack. So for today's video, we're going to talk about the content of Module 2, which is about standard atmosphere. So why is it necessary to set the standard altitude? So to answer that question, it is necessary to set the standard altitude because this will allow the aircraft to gain altitude in a short time as possible, an important goal as a precaution against engine or other problems in takeoff. So, what are the different types of altitude? So, there are six types of altitude. First is geometric altitude. So, it is the altitude measured with reference to the Earth's surface. Second is absolute altitude. So, it is the altitude measured with reference to the Earth's center. It has a formula of HA is equal to R plus HG, where R is the radius of the Earth and Hg is the geometric height. So third is geopotential altitude. So it is a viscous altitude defined to compensate for variation of gravity with respect to height. It can be considered a gravity adjusted height. So fourth is pressure altitude. So it is the altitude that your aircraft performs at on a non-standard day. And density altitude is a pressure altitude corrected for non-standard temperature. So as temperature and altitude increase, air density decreases. And lastly, temperature altitude. So as altitude increases, temperature decreases. Various factors are responsible for this, including air pressure and water vapor content. So is it possible to that geopotential altitude is equal or same in terms of value with geometric altitude? If yes, then when and how? So kung makikita natin, hydrostatic equation has a similarity with geopotential altitude equation kung saan yung difference lang nila is in terms of height, where hydrostatic equation has a DHG, meaning geopotential height, while in the potential altitude equation has a DH kung saan ang meaning ng H is new altitude. So let's derive and interpret the hydrostatic equation. So balikan natin yung lesson 1 where force is equal to mass times acceleration, where mass is equal to density times volume. So therefore, force is equal to negative raw volume times gravity. Negative since downward yung pressure. So, yung mangyayari is negative raw times 1 times change in geopotential altitude times gravity. So, nakuha natin tong 1 times 1 times DHG sa cube kung saan makikita sa module 2. And we will arrive to a formula of negative rho g dHg. So in this part, we will arrive in a formula of the hydrostatic equation kung saan yung part 1 is makikita sa cube within the module 2 content. Then transpose, and we will arrive to a formula of Tp is equal to negative rho g dHg. Same with this part kung saan we keep on deriving formulas to come up with the final answer of Tp is equal to negative rho dHg. So let's now describe the relationship of the properties of air whenever the altitudes change. So in this graph, we have two parts, namely the temperature and altitude. So the constant temperature is called isothermal region, while yung constant altitude is the gradient region. So, sa gradient region, merong apat na region, while sa isothermal region, merong tatlong region. So, sa gradient region, meron tayong 0 to 11 kilometers or is equal to 36.089 feet. So, bakit hanggang 11 kilometers lang? Kasi pag sumobra na yon, mapupunta na tayo sa space vehicles, which is not yet tackled in our module. So, temperature varies with respect to height over altitude. So, temperature variation in gradient region is equal to change in run over change in rise. So, T minus T0 over H minus H0 is equal to dt over dH, which is the formula of lap race. So, sa gradient region, meron tayong constant value ng lap race na 0.00651 Kelvin per meter. Second is 0.00356 Rankine over feet. And lastly, 6.51 Kelvin over kilometers. So here, kung makikita natin dito, ito yung derivation of formula ng gradient region, which magka-come up sa formula na temperature is equal to TO or T0 plus laps race times H minus H0. So the formula of pressure variation in gradient region is equal to dP over P is equal to negative rho G0 dH over PRT. So hydrostatic equation yung negative rho GH negative rho G0 dH, and equation of state or ideal equation yung rho RT, kung saan ika-cancel natin yung density, which will come up to a equation of, formula of dP over P is equal to negative G0 dH over RT. So in this formula na P over P0 is equal to T over T0 times with or a upper part na negative G0 over laps race times R when pressure or temperature yung hahanapin. And mas mag-elaborate pa to if gamitin natin itong P over P0 is equal to 1. 1 dahil dito sa mas in-elaborate na T0 plus lap raise H over T0. Then, yung come up answer na negative G0 over laps race times gravity is 5.26. So, ito naman, paghahanapin natin yung density when temperature is given, or hanapin natin yung temperature when density is given. Though they have a similarity dun sa naunang equation, but the difference is 4.26 na siya instead of 5 point something, since i-minus na natin siya sa negative 1 or minus 1. So, density variation in gradient region na tayo, which magkakama sa formula na P over P0 is equal to rho RT, kung saan at altitude H yung formula na yon, and over P0 RT0, which is at altitude H0 na yon. So, we will cancel R for both sides. So, P over P0 is equal to rho T over P0 T, rather rho 0 T0. So, here, mas inelaborate yung formula where minultiply sila both ng T over TO. And we will have the final formula of rho over rho 0 is equal to T over TO. Then the upper part is GO, rather G0 over lapse raise times R minus 1. So here is where pressure variation in isothermal region will be tackled, where it has an equation of dP over P is equal to negative rho G0 dH over rho RT. Kung saan hydrostatic equation yung negative rho G0 dH and equation of state or ideal gas yung rho RT. Then they canceled density, which is rho. So the final formula will be dP over P is equal to negative G0 dH over RT. So here, kung makikita natin may number 11 sa P in terms of log since hanggang 11 kilometers nga lang yung pag-aaralan natin as of now. So it will arrive in a formula of P over P11 is equal to E raised to negative G0 over RT times H minus H11. So density variation in isothermal region has a formula of P over P1, rather P11 is equal to rho RT over rho 11 RT11, where rho RT is at altitude H and rho 11 RT11 is at altitude at 11. So if we will elaborate the formula, we will come up with a final formula of P over P11 is equal to rho over rho 11 equals to E raised to G0 over RT times to H minus H11. So let's have an example of our module 2, which we have a question of calculate the standard atmosphere values of temperature, pressure, and density at geopotential altitude of 14 kilometers. So if we will go back to our lesson, for isothermal layers have a formula of P over P11 is equal to E over G0 over RT times H minus H11. So 14 kilometers yung hinahanap. Then multiply to P 11 kilometers times E over G0 over RT minus H1. Then ilagay natin yung value ng P11 which is 22606.82 Pascal times E minus yung value ng gagamitin natin gravity na 9.81 meter per second square over yung R ng air which is 287.08 joules per kilogram mass times Kelvin multiplied by the given temperature which is 216.66 K kung saan nakikita yun sa graph multiplied by 14 meters minus 11 meters. Ginawa natin siyang meters para ma-cancel out instead of kilometers. Pero pwede din naman. Pero kailangan same lahat nung units. And we will come up with the final answer of pressure of 11 na 14084.73 Pascal. So in finding the value of density, gagamitin natin yung formula na rho over rho 11 is equal to E um, over G0 RT times H minus H11. Then substitute the value of each given kung saan same din sila ng mga values sa gravity, sa R, sa T, sa H. And we will come up with the answer of 0.227 kilogram mass over meter cube. So let's now proceed to the second question. So the question is, if an airplane is flying at a altitude where the actual pressure and temperature are 4.72 times 4 raised to 4 yan dapat, Pascal and 255.7 Kelvin, respectively, what are the pressure, temperature, and density altitudes? So if we're going to recall the formula of pressure altitude, we will have the formula of P over P0 is equal to 1 plus lapse rate times H over T0 and multiply by 5.26. Substitute the values of each given. Then we will arrive with the answer of 5992.92 meters or 6 kilometers na siya. Pag kinonvert natin, magiging 6 since in-round off. So to find the height, we will use the formula of T is equal to T0 plus lapse race times H minus HO, where HO is equal to 0 kilometers. And then, sinubstitute natin yung value, then shift solve na lang siya para mas madali. And we will arrive to the answer of 4993.85 meters or 5 kilometers. So for density altitude, we will use the formula of P is equal to rho RT, where kung ayusin natin siya or ma-manipulate, rho is equal to P over RT. Then we will substitute the given values, then we will come up with the final answer of 0.643 kilogram mass over meter cube. Then we will also use the formula of rho over rho 0 is equal to 1 plus lapse race times H over T0 over 4.26. And substitute the value and shift solve na lang ulit kung ano yung hahanapin. Then we will arrive with the answer of 6224.83 kilometers or 6.22 kilometers.